This is Exam 1, Test 1 Review, Detailed Solution, Calculus 1, Engineering STEM Calculus. In this exam review, we'll cover Chapter 1 and Chapter 2. Chapter 1 is Limits. We'll use limits using graphics. We'll do limits of piecewise functions. And we'll go do limit at infinity, which is a horizontal asymptotes. We'll also look at vertical asymptote. We'll look at holes, x-intercept, and y-intercepts. We'll also do some basic algebra of limits and some basic arithmetic of limits. We'll also use epsilon delta to proof of limits. Epsilon delta proof of limits. Okay. Then we'll move on to Chapter 2, which is definition of derivative. We're going to use the definition of the derivative to find derivative of basic functions. We'll also find slope of the tangent of the derivative, equation of the tangent, then also find the horizontal tangent points. Then we'll apply product rules and chain rules and quotient rule to find some derivative, the derivative of some complex functions. Then also we'll do a combination of product rule, quotient rule, and chain rule to find the derivative of more complex function. Well, we'll move on and we'll do implicit differentiation to find the horizontal tangent point and vertical tangent point of a circle. Then we'll do related rate application, physics application, both docking. Then we'll do linear approximation differentials of nonlinear functions. We'll do also more applications of derivatives. This exam test review is additional review to your professor and instructor exam review. It is good review tutorial for students in Calculus 1, Calculus 2, Calculus 3, Business Calculus, AB Calculus. Also watch my Calculus 2 exam review, Business Calculus exam review, Business Math exam review, Trigonometry exam review, College Algebra exam review, Development Math exam review. I'm sharing this with you only as additional help in addition to your professor instructor exam test review, which should be your main essential review. This is a complete review of Chapter 1, the limits of a function, calculating limits, continuity, limits to infinity, then Chapter 2, derivative and rates of change, the derivative of a function, basic differentiation formulas, the product and quotient rules, the chain rule, implicit differentiation, related rates, linear approximation, and differentials. Before we start, please subscribe, share, and like, and ask your friends to subscribe, share, and like, and thank you. My name is Osman Anwar. I have been Professor of Engineering and Business Mathematics in Dallas, Texas, USA. Please subscribe to my 4 education channels, share and like, and ask your friends to subscribe, share, and like. Links are in the description. My 4 education channels are specifically for university and college students and high school students. Channel 1 is for business students. It has business calculus, business math, and mathematics of finance. Channel 2 is for engineering STEM students. It has Calculus 1, Calculus 2, and high school AP Calculus. Eventually, I will add Calculus 3, differential equation, linear algebra, and so on. My channel 3 it has trigonometry and high school geometry. Channel 4 has college algebra, intermediate algebra, which is a development math, and high school algebra 1 and algebra 2. In all my channels, I have 3 plans. Plan number 1 is I have exam reviews and test reviews that I have solved with my students in classroom, and my students have used those exam reviews and test reviews to excel in my class. I will convert those exam reviews and test reviews into video presentations and share them with you. Plan number 2 is I have been solving many mathematics problems, business applications, engineering applications in classroom with my students. I will convert those detailed solutions into video presentations and share them with you. Plan number 3 is I will show you how to use technology such as Excel and graphic calculators, how to use technology to solve mathematics problems, business applications, and engineering applications. Once again, please subscribe, share, and like, and ask your friends to subscribe, share, and like. Here are details of my plans. Plan number 1 is share with you video presentations of my exam reviews and test reviews. Plan number 2 is share with you video presentations of my detailed solution to examples and applications. Through my plans, you will learn how to succeed and get A in business calculus, how to succeed and get A in business math, how to succeed and get A in engineering calculus, how to succeed and get A in high school AP calculus, how to succeed and get A in trigonometry, how to succeed and get A in high school geometry, how to succeed and get A in college algebra, how to succeed and get A in intermediate algebra, which is development math, how to succeed and get A in high school algebra 1 and algebra 2. I will show you how to use technology to solve mathematics applications / problems, technologies such as Excel, graphic calculator, how to use technology to solve business math applications, engineering math applications, mathematics of finance applications, calculus derivatives and integrals, trigonometry, college algebra, intermediate algebra, development math, high school algebra 1 and algebra 2. Once again, please subscribe, share, and like, and ask your friends to subscribe, share, and like, and thank you very much. Number 1 is limit using graphs. Use the graph of f of x to find the following limits whenever they exist. A. limit as x approaches 1 from the left, f of x. So you walk on this line from the left as you approach 1, f of x, which is y, approaches 4. Then b, limit as x approaches 1 from the right of f of x. So you walk on this blue line from the right as you approach 1, f of x, which is y, approaches 0. So limit from the left is 4, limit from the right is 0. So they are not equal. That means the limit as x approaches 1, f of x does not exist. Then D is, you stand here on 1, you look up, it is a hole, does not exist. Then where you stand, f of 1 is 0. So that means this is the function continue or discontinue. It is obviously, you can see the big gap here, the hole. That means this function is discontinue. Number 2 is limit of piecewise function f of x equals 9x minus 1 for x is less than 1, and f of x is equal to 10 minus x squared for x greater or equal to 1. So limit as x approaches 1 from the left, which is obviously when x is less than 1. That means it is f of x equals 9x minus 1. Then f of 1 is 9 times 1 minus 1, which is f of 1, which is equal to 8. So limit as x approaches 1 from the left, it is 8. Then limit as x approaches 1 from the right, which is obviously when x is greater than 1, and that is the function is f of x is equal to 10 minus x squared. Then f of 1 is again 8. So the limit as x approaches 1 from the right, f of x is equal to 8. So the limit from the left is 8, the limit from the right is 8. That means the limit as x approaches 1, f of x, it exists and it is equal to 8. Then f of 1 is obviously when x equals 1, which is f of x equals 10 minus x squared. Then f of 1 of that is 8. So the limit from the left is 8, from the right is 8, then the limit exists, it is 8, and the f of 1 is 8, that means the limit, the function is continuous. Number 3 is use algebraic method to find the limit. Use a property of limit and the algebra method to find the limit if they exist. A. Limit as x approaches 7 of x squared minus 8x plus 7 over x squared minus 6x minus 7. So if you evaluate this at x equals 7, you will find it is 0 over 0, which is indeterminate. Indeterminate is not an answer. That means we have to do some algebra before we take the limit. So if you factor the numerator to x minus 1 times x minus 2 and the denominator to x plus 1 times x minus 7, x minus 7 cancels x minus 7, then this reduces into limit as x approaches 1 of x minus 1 over x plus 1, which is 7 minus 1 over 7 plus 1, which is 6 over 8, which is equal to 3 over 4. B is limit as x approaches minus 2 of x to the 4 minus 4x squared over x squared plus 8x plus 12. Then if you evaluate it at minus 2, it's going to be 0 over 0, which is indeterminate. Indeterminate is not an answer. So we have to do some algebra before we take the limit. So when you take the denominator and factor it into x squared times x plus 1 times x minus 2, and the denominator to factor it to x plus 2 times x plus 6, x plus 2 cancels x plus 2, then this simplifies into x squared times x minus 2 over x plus 6. Then when you take limit as x approaches minus 2, this is minus 2 squared times minus 2 over minus 2 plus 6, which is 4 times minus 4 over 4. 4 cancels 4, so this is minus 4. Number 4 is find sum, difference, product, and quotient of limit. If limit as x approaches 3 f of x is equal to 4, this is known, and limit as x approaches 3g of x is minus 2, find limit as x approaches 3 5 f of x plus 2g of x, and this is equal to limit as x approaches 3 5 f of x plus limit as x approaches 3 2g of x, which is this is 5 limit as x approaches 3 f of x plus 2 limit as x approaches 3g of x, but we know limit as x approaches 3 f of x is known, it is 4, and limit as x approaches 3g of x is minus 2. That means this is 5 times 4 plus 2 times minus 2, which is 20 minus 4 equals 16. B is limit as x approaches 3 f of x minus 2g of x, which is limit as x approaches 3 f of x minus limit as x approaches 3 2g of x. So this is equal to limit 3 limit as x approaches 3 f of x minus 2 limit as x approaches 3g of x. So this limit as x approaches 3 f of x is 4, limit as x approaches 3g of x is minus 2, so this is 3 times 4 minus 2, which is 12 plus 4, which is 16. Number C is limit as x approaches 3 to f of x times g of x, so this is 2 limit as x approaches 3 f of x times limit as x approaches 3g of x, which is equal to 2 times 4 times minus 2. So this is equal to minus 60. Number D is limit as x approaches 3 16 f of x over 2g of x, and that is limit as x approaches 3 8 or f of x over g of x. Then this is 8 limit as x approaches 3 f of x over limit as x approaches 3g of x, which is 8 times 4 over minus 2, which is minus 60. Number 5 is limit at infinity, vertical and horizontal asymptote, holes, and intercepts, x and y intercept. For the following function, find limit at infinity, which is a horizontal asymptote, vertical and horizontal asymptotes, hole, the x and y intercepts. So the function is x squared plus 5x plus 6 over x squared minus 9. If you factor the numerator, you will factor to x plus 2 times x plus 3. The denominator will factor to x plus 3 times x minus 3. The x plus 2 x plus 3 cancels x plus 3. Then this becomes simplified to x plus 2 over x minus 3. So to find the x-intercept, set the numerator equal to 0, which is x plus 2 equal to 0, x equals minus 2 is the x-intercepts. To find the y-intercept, simply it is f of 0, which is 0 plus 2 over 0 minus 3, y equals minus 2 over 3. That is the y-intercept. To find the vertical asymptote, set the denominator equal to 0, which is x minus 3 equal to 0, x equals 3, which is the vertical blue line, is the vertical asymptote. To find the whole, set the eliminated term equal to 0. We eliminated x plus 3 equal to 0, x equals minus 3 is the whole. Then to find the horizontal asymptote, simply take limit as x approaches infinity of x plus 2 over x minus 3, which is if you plug infinity, is infinity over infinity, which is indeterminate. Then we have to do some algebra before we take the limit, go to infinity, which is the algebra is divide the top and the bottom by x, by the highest power, which is x, divide top and bottom by x. Then this becomes limit as x approaches infinity, x over x plus 2 over x minus 3 over x. So this is limit as x approaches infinity, 1 plus 2 over x over 1 minus 3 over x. Then this is 1 plus 2 over infinity over 1 minus 3 over infinity. This is 0 and this is 0, so this is y equals 1 plus 0 over 1 minus 0, which is 1 over 1, y is equal to 1, which is the yellow horizontal line, that is the horizontal asymptote. Okay. Number 6 is epsilon delta definition of a limit, which is precise definition of a limit. Prove that limit as x approaches 3 of 3x minus 8 equals 1. So to prove using epsilon delta definition of a limit, first A, find the limit as x approaches 3 of x minus 8, which is 3 times 3 minus 8, which is 9 minus 8 equals 1. Then if absolute value of x minus 3 is between 0 and delta, then absolute value of the function 3x minus 8 minus the limit, which is 1, is less than epsilon. Now the question is, what is the relationship between delta and epsilon for this to happen? So now C is, but now look at absolute value of 3x minus 8 minus 1 is equal to 3x, absolute value of 3x minus 9, which is equal to, if you factor out 3, it is absolute value of 3 times x minus 3, which is equal to 3 times absolute value of x minus 3. Therefore, we want, if absolute value of x minus 3 is between 0 and delta, then 3 times absolute value of x minus 3 is less than epsilon. But not now that 3 times absolute value of x minus 3 less than epsilon means absolute value of x minus 3 is less than epsilon over 3. So that means let's choose then delta to be epsilon over 3. So then we can then write, if absolute value of x minus 3 is between 0 and delta, which means absolute value of x minus 3 is between 0 and epsilon over 3, because that's what delta is, then 3 times absolute value of x minus 3 is less than epsilon, if you multiply this by 3. That means absolute value of 3x minus 8 minus 1 is less than epsilon. Therefore, by the definition of a limit as x approaches 3 of 3x minus 8 is equal to 1. Okay, number 7 is we're going to find the derivative of f of x equals x squared plus 3x plus 5, which we know it is 2x plus 3, but we're going to use the definition of derivative to find this 2x plus 3. So the definition of the derivative is f prime of x equals limit as h approaches 0 f of x plus h minus f of x over h. And that is equal to, we're going to take x plus h and substitute it into every x. So this is x plus h squared plus 3x plus h plus 5, then minus f of x minus x squared plus 3x plus 5 over h. Then this one is x squared plus 2xh plus h squared, and this one is 3x plus h plus 5 minus x squared minus 3x minus 5 over h. Then x squared cancels x squared, 3x cancels 3x, 5 cancels 5. Then this becomes equal to limit as x approaches 0 2xh plus h squared plus 3h over h. Then factor out h, then this becomes limit as h approaches 0 h times 2x plus h plus 3 over h. The h cancels the h, then this is limit as x approaches 0 2x plus h plus 3. Then this is equal to 2x plus 0 plus 3, which is 2x plus 3. Then to find the slope of the tangent, instantaneous rate of change at x equals 4, then this is f prime of 4, which is 2 times 4 plus 3, which is 8 plus 3, which is equal to 11. So that's the slope of the tangent. Number 8 is power, constant, and coefficient, and sum and different rules of a derivative. So A is f of x equals 2x to the 12 minus 5x to the 6 plus 9x to the 4 plus x minus 5. So we're going to apply the power rule here simply to find the derivative. F prime of x is equal to 24 x to the 11 minus 30 x to the 5 plus 36 x to the 3rd plus 1 minus 0, which gives you the derivative f prime of x is 24 x to the 11 minus 30 x to the 5 plus 30 x to the 3rd plus 1. Then evaluate this at 1 to find the slope of the tangent. F prime at 1 is 24 times minus 1 to the 11 minus 30 times minus 1 to the 5 plus 36 times minus 1 to the 3rd plus 1, which is equal to minus 29. Number C is g of x equals 3 over x to the 5 plus 2 over x to the 4 plus 6 times cubic root of x. Then rewrite this as g of x equals 3x to the minus 5 plus 2x to the minus 4 plus 6x to the 1/3. Then the derivative of that is minus 15x to the minus 6 minus 8x to the minus 5 plus 6 times 1/3 x to the minus 1 over 2. Then that is the derivative is minus 15 over x to the 6 minus 8 over x to the 5 plus 2 over cubic root of x squared. Then evaluate that at minus 1 to find the slope of the tangent. g prime at minus 1, which is m, is equal to minus 15 over minus 1 to the 6 minus 8 over minus 1 to the 5 plus 2 cubic root of minus 1 squared, which is, this is minus 15 plus 8 plus 2, which is equal to minus 5. Number 9 is find the slope of a tangent line and the equation of the tangent line of the function h of x equals x cubed minus 5x squared plus 7 at a point xy equals 1, 3. So first find the derivative, which is 3x squared minus 10x. Then find the slope of the tangent at 1, x equals 1, so that's h prime at 1, which is equal to 3 times 1 squared minus 10 times 1, which is 3 minus 10, which is minus 7, so that is your slope m. Then find the equation of the tangent line, y equals mx plus b, that is y equals m, we know it is minus 7, minus 7x plus b. We also know when y is 3x is 1, so this is 3 equals minus 7 times 1 plus b. Then b is equal to 3 plus 7, b is equal to 10. That means the equation of the tangent line is y equals minus 7x plus 10. Number 10 is horizontal tangent line. So find the maximum and minimum of the graph. So we're going to find the coordinates of the tangent line, the max and the min, of the function f of x equals x cubed over 3 minus 9x plus 5. So first find the derivative. The derivative is 3x squared over 3 minus 9 plus 5 plus 0. The derivative of 5 is 0. So that's equal to x squared minus 9. So that's the derivative. Then set that equal to 0 to find the x value of the horizontal tangent points, which is f prime of x equal to 0, which is x squared minus 9 equal to 0. X squared equals 9, that means x equals plus or minus 3. Then evaluate y, which is f of x, at 3 and minus 3. So f of 3 is 3 to the third over 3 minus 9 times 3 plus 5, which is equal to minus 13. And the f of minus 3 is minus 3 to the third over 3 minus 9 times minus 3 plus 5, which is equal to 23. Then the coordinates of the tangent, horizontal tangent, are xy. One of them is 3 minus 13, which is, this is the minimum. Then minus 323, this is a max. So this is a mean, this is a max. Number 11 is business of application of average rate of change of revenue. If the total revenue function for a blender is r of x equals 36x minus 0.01x squared, where x is the number of units sold, what is the average rate of change in revenue r of x as x increases from 10 to 20 units? So x1 is 10, x2 is 20. Then the average rate of change is y2 minus y1 over x2 over x1. Then y2 is r of x2, y1 is r of x1, which is r of 20 minus r of 10. Then x2 minus x1 is 20 minus 10. Then simply evaluate r at 20 and 10. So that is 36 times 20 minus 0.01 times 20 squared minus 36 times 10 minus 0.01, 10 squared over 20 minus 10. Then this is 36 times 20 minus 10 minus 0.01 times 20 squared minus 10 squared over 20 minus 10. Then this is equal to 36 times 10 minus 0.01 times 20 squared minus 10 squared, which is 400 minus 100, which is 300. Then this is 360 minus 3 over 20 minus 10, which is 357 over 10, which is 35.7 per unit, dollars per unit. So that's the average rate change of revenue is $35.7 per unit. Number 12 is derivative formula. We're going to do product and quotient rule. So A is f of x equals x squared plus 1 times x cubed minus 4x. So this is the first function times the second function. Then the product rule of the derivative is f prime of x equals the first function times the derivative of the second function plus the second function times the derivative of the first function. So that is f prime of x is equal to x squared plus 1 as it is times the derivative of x cubed minus 4x, which is 3x squared minus 4, plus the second as it is x to the third minus 4x times the derivative of the first derivative function, which is 2x. Then the first one is 3x to the 4 minus 4x squared plus 3x squared minus 4. And this one, the second one, is 2x to the 4 minus 8x squared. Then when you add all this up, it is 5x to the 4 minus 9x squared minus 4. Okay. Then when you evaluate this at minus 2 to find the slope of the tangent, so f prime at minus 2 is 5 times minus 2 to the 4 minus 9 times minus 2 squared minus 4 equals 40. Number C is quotient rule. G of x equals x squared plus 1 over x plus 3. Then the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Then g prime of x is the bottom is x plus 3 times the derivative of the top, which is 2x, minus the top, which is x squared plus 1 times the derivative of the bottom, which is 1, over the bottom squared, which is x plus 3 all squared. So the top is then 2x squared plus 6x minus x squared minus 1 over x plus 3 squared. So this is x squared plus 6x minus 1 over x plus 3 all squared. Then g prime, when evaluated at 2 to find the slope of the tangent, then this is 2 squared plus 6 times 2 minus 1 over 2 plus 3 all squared, which is 3 over 5. So that's the slope of the tangent. M is equal to 3 over 5. Number 15 is physics application, instantaneous velocity and acceleration. A particle travels as a function of time according to the formula S of t equals 100 plus 10t plus 0.01 t cubed, where S is in meters and t is in second. Find the distance, instantaneous velocity, and the acceleration of a particle when t is equal to 2. So known facts are derivative of distance is velocity and derivative of velocity is acceleration. So A, find the distance at t equals 2. The distance formula is given. So S of t is equal to 100 plus 10t plus 0.0 t cubed. Then S of 2 is 100 plus 10 times 2 times plus 0.01 times 2 cubed. So this is 100 plus 20 plus 0.08, which is 120.08 meter. B is find the instantaneous velocity at t equals 2. So now we don't have a formula for velocity, but we know the derivative of distance is velocity. So we take the derivative of the distance, which is s of t. The derivative of 100 is 0. The derivative of 10t is 10. The derivative of 0.01 t cubed is 0.03t squared, and that is the velocity formula. So that means V of 2 is 10 plus 0.032 squared, which is 10 plus 0.03 times 4, which is 10 plus 0.12, which is 10.12 meter per second. Then C is find the instantaneous acceleration at t equals 2. We don't have the formula for acceleration, but we have formula for velocity now. If we take the derivative of the velocity, we get acceleration. So the derivative of 10 is 0. The derivative of 0.03 t squared is 0.060. Then the acceleration formula is A of t equals 0.060. Then A of 2 is 0.06 times 2, which is 0.12 meter per second. Number 14 is derivative chain rule and power rule. So use these rules to find the derivative of the following function. So y equals 3 over 4 times x to the 5 minus 2x cubed plus 5 to the 8. So you do not want to multiply this 8 times by itself and take the derivative. That will be a huge work. So what we need to do is we need to substitute what is inside with u. So what is inside is x to the 5 minus 2x cubed plus 5. We'll call that u. So if we call that u, then y becomes 3 over 4 u to the 8. Then it takes step by step. A, find dy by du, which is 3 over 4 times 8u to the 7, which is 6u to the 7. Then B, find du by dx. Then that is 5x to the 4 minus 6x squared. Okay. Then to find dy by dx, multiply a times b. That is dy by du times du by dx. Du cancels du, that gives you dy by dx, and that is equal to dy by du is 6u to the 7. Du by dx is 5x to the 4 minus 6x squared. Then that is equal to 6, but we know u is x to the 5 minus 2x cubed plus 5, so that is substitute that, so this becomes 6 x to the 5 minus 2x cubed plus 5 to the 7 times 5x to the 4 minus 6x squared, and that is equal to, if you factor out x squared from here, then this becomes 6x squared times 5x squared minus 6 times x to the 5 minus 2x to the 3rd plus 5 all to the 7. Okay. Number 15, also we're going to do chain rule and power rule to find the derivative of y equals square root of 3x squared plus 4x plus 9. This is not easy to integrate as it is. So what we'll do is we're going to call what is inside the radical, we'll call it u. So then u is 3x squared plus 4x plus 9. Then y becomes square root of u, which is u to the half. Then take step by step. First find dy by du, which is 1 over 2u to the minus half, which is 1 over 2 square root of u. Then we're going to find du by dx, which is 6x plus 4. Then dy by dx is simply a times b. That is, dy by dx is dy by du times du by dx. Du cancels du, dy by dx. And that is, dy by du is 1 over 2 square root of u. Du by dx is 6x plus 4. So this is equal to 1 over 2 square root of, but u we know it is 3x squared plus 4x plus 9, so just put it back. Times 6x plus 4. Then if you factor out 2 from here, then this is 3x plus 2 over square root of 3x squared plus 4x plus 9. Number 16 is we're going to use the power rule, the product, quotient, and chain rule to find derivative in combination. Use derivative of combination to find the derivative of this more complex function. So this is 5 over 3x to the third times 4x to the 5 minus 5 to the third. So this is obviously product. We're going to use here product rule within the chain rule. So the product rule is the first times the derivative of the second plus the second times the derivative of the first. The first is 5 over 3 x to the third. The second function is 4 x to the 5 minus 5 to the third. So the derivative becomes then 5 over 3x to the third times 4x to the 5 minus 5 to the third, the derivative of that whole thing, plus 4x to the 5 minus 5 to the third, which is the second, times the derivative of the first, which is 5 over 3x cubed, derivative of that. So this is equal to 5 over 3x cubed, and the derivative of this is 4x to the 5 minus 5 squared times the derivative of the inside, which is 20x to the 4, and that's the chain rule, plus the derivative of this is 4x to the 5 minus 5 to the third times the derivative of the first, which is 5 over 3x squared. Then here, this 3 cancels this 3, this is 5x to the third times 4x to the 5 minus 5 all squared times 20x to the 4. And here this 3 cancels this 3, this is then 4x to the 5 minus 5 to the third times 5x squared. Then here we can see 5x to the third and 5x squared here. So we can split this one then to f of 5x squared times x times 4x to the 5 minus 5 squared times 20x to the 4 plus 4x to the 5 minus 5 to the third times 5x squared. Then from here we can factor out 5x squared. We can also factor out 4x to the 5 minus 5 all squared. Then what is left in the first one is 20x to the 5. In the second one, what is left is 4x to the 5 minus 5. Then this becomes 5x squared times 4x to the 5 minus 5 squared times 24x to the 5 minus 5. Number 17 is we're going to use derivative rules in combination to find the derivative of y equals 2x minus 1 over x squared plus x all to the 4. And this is obviously the power rule times the derivative of the inside, which is a quotient rule within the chain rule. So that means this is y prime is equal to, we're going to take the 4 down, 4 2x minus 1 over x squared plus x to the third times the derivative of the inside, which is the quotient rule, bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Then this becomes the bottom, which is x squared plus x times the derivative of the top, which is 2, minus the top, which is 2x minus 1 times the derivative of the bottom, which is 2x plus 1, over the bottom squared, which is x squared plus x all squared. Then this is equal to 4 times 2x minus 1 over x squared plus x to the third times the derivative of the top is 2x squared plus 2x minus 4x squared plus 2x minus 2x minus 1 over x squared plus x all squared. Then here 2x cancels the 2x. Then this becomes 4 times, we can split this into 2x minus 1 to the third over x squared plus 1 plus x to the third. Then here this becomes minus 2x squared plus 2x plus 1 over x squared plus x to the second. So the bottom is, we can combine that into x squared plus x to the 5. Then the top is 4 times 2x minus 1 to the third times minus 2x squared plus 2x plus 1. So the whole thing is then is equal to 4 times 2x minus 1 to the third times minus 2x squared plus 2x plus 1 over x squared plus x to the 5. Number 18 is implicit differentiation. Use implicit differentiation to find dy by dx, vertical tangent points and horizontal tangent points of the following function, which is a circle x squared plus y squared minus 9 equal to 0. So A first finds the derivative, which is 2x plus 2y dy by dx. The derivative of 9 is 0, the derivative of 0 is 0. Then this is 2y dy by dx equals minus 2x. That means dy by dx is minus 2x over 2y, which is dy by dx is minus x over y. Then to find the horizontal tangent point, set dy by dx equal to 0, which is minus x over y equal to 0, which is x equal to 0, equal 0. Then x squared plus y squared minus 9 equal to 0 means 0 squared plus y squared minus 9 equal to 0. That is y squared equals 9. Then y equals plus or minus 3. That means the horizontal tangent points are x, y. So when x is 0, y is minus 3 and 3. So those are the two horizontal tangent points, which is minus 0, minus 3, and 0, 3. those are the horizontal tangent points. Then C is find the vertical tangent points. For the vertical tangent points, we know dy by dx is minus x over y. That means dx over dy is minus y over x. Then we said minus y over x equal to 0. That gives us y equal to 0. That means x squared plus y squared minus 9 equal to 0 means x squared plus 0 squared minus 9 equal to 0. That means x squared equals 9. That means x equals plus or minus 3. So that means xy, when x is minus 3 and 3y is 0. So that is the vertical tangent points, which is minus 3, 0 and 0, 3. Number 19 is related rate, physics application, boat docking. Suppose that a boat is being pulled towards a dock by a winch that is 5 feet above the level of the boat deck as shown in figure. Okay, so this is constant then, 5. If the winch is pulling the cable at a rate of 3 feet per minute, that means R is changing at 3 feet per minute. At what rate is the boat approaching the dock, which is dx by dt, when it is 12 feet from the dock? X is known, it is 12 feet from the dock. Okay, so the first thing is we know y is constant 5 and the x is 12, it is given to us. Then we need to find r at that point. So that means r squared equals x squared plus y squared, my Pythagorean theorem of this triangle. Then that is r squared equals 12 squared plus 5 squared, which is r squared equals 144 plus 25. That is r squared equals 169. That means r is equal to 13. Now, in equation r squared equals x squared plus y squared, we know that r is changing, x is changing, but y is constant. So we can just put the 5 squared there. Okay. Then find the derivative with respect to time, that is related rate. So both of them are changing with time, so take the derivative of everything with respect to time. So then this becomes the derivative of r squared is 2r dr by dt equals the derivative of x squared is 2x dx by dt. The derivative of 5 squared is 0. Then this is 2r over 2x dr by dt is equal to dx by dt. Then dx by dt is, this 2 cancels 2, so this is r over x dr by dt. So now we have all the information you need to find dx by dt, which is how fast is the boat approaching the dock. So that is, we know r is 13, x is 12, dr by dt is, we know it is 3 feet per minute. That means this is 13 over 12 times 3. That means dx by dt is 13 over 4 feet per minute. So what that means is when the winch is pulling the boat at the rate of 3 feet per minute, then the boat is approaching the dock at the rate of 13 over 4 feet per minute. Number 20 is linear approximation of function. Find the linear approximation of the function f of x equals square root of 1 minus x at a equals 0. And use it to approximate the numbers square root of 0.9 and the square root of 0.99. Okay, and illustrate by graph f of x and the tangent line. Okay, first find the derivative of f of x equals square root of 1 minus x. So this is f of x is equal to 1 minus x to the half. That means f prime of x is 1 over 2 1 minus x to the minus half times the derivative of the inside times minus 1, which makes this minus half. So that means f prime of x is equal to minus 1 over 2 square root of 1 minus x. Then evaluate at a equals 0, f of a is equal to square root of 1 minus a. F prime of a is equal to minus 1 over 2 square root of 1 minus a. Then at a equals 0, f of 0 is 1. F prime of 0 is 1 minus 1 over 2. So 0 here, it is minus 1 over 2. Then linear approximation of the function f of x equals square root of 1 minus x at a equals 0 is equal to L of x equals f of a plus f prime of a times x minus a. But we know a is 0, so that means L of x is f of 0 plus f prime of 0 times x minus 0. So that is L of x, f of 0 is 1, f prime of 0 is half, so that means L of x is equal to 1 minus half x. Okay, therefore f of x equals square root of 1 minus x is approximately 1 minus half x, and that is equal to Lx. So now to find f of x equals square root of 1 minus x, which is equal to square root of 0.9, then that means 1 minus x is 0.9, then x is 1 minus 0.9, then x is 0.1, therefore square root of 0.9 is approximately L of 0.1, which is 1 minus half times 0.1, which is 1 minus 0.05, which is equal to 0.95. Then f of x equals square root of 1 minus x equals square root of 0.99. This means 1 minus x is equal to 0.99. That means x is 1 minus 0.99. That is x equals 0.01. Therefore, square root of 0.99 is equal to approximately L of 0.01, which is 1 minus half times 0.01, which is 1 minus 0.005, which is equal to 0.995. And here is the graph. The function is y equals square root of 1 minus x is this curve. Then the linear approximation at a equals 0 is y equals 1 minus half x, and that is the linear approximation. This line is the linear approximation of this curve at a equals 0. Once again, please subscribe, share and like, and ask your friends to subscribe, share and like, and thank you.